Hello everyone, my name is Kelvin. Today I would like to talk about the Physics 1 Lab 1, which is about the constant velocity of an object and which is the analysis of Newton's second law. So here's the table of contents. First of all, I will introduce the purpose of Lab 1 and then I will talk about some basic theories about this lab. So it's about Newton's second law, principle of momentums, and how to derive the velocity update formula. And also, I'll talk about some practical plan overview. And after that, I'll explain the specific step of how I conduct the practical, including the video production of the moving object, the tracker analysis by calibration, and also the coding of flow script. Lastly, I will do some data analysis of comparing the graphs of theoretical and real data, explain the errors I made, and also discuss on some further questions you might wonder. First of all, I would like to explain the purpose of Lab 1. So our purpose of Lab 1 is basically want to demonstrate Newton's second law in reality by comparing an object moving in constant velocity, which is like moving in constant speed and constant direction. And in this case, a marker, and we compare with a computational model we produce by using the coding of flow script. And then after that, I will talk about some theories and procedures in this lab. So Newton's second law states that the acceleration of the body is directly proportional to the net force which is acting on the body and inversely proportional to its mass, which means F net equal ma. And we can use A equals V minus U over T, and then we can also substitute in the momentum formula, and then we can derive the principle of momentum, which is F net equals to the derivative of momentum over time. And then after that, we can just continue to substituting, and we can got the velocity update formula, which is in it v final equals to v initial plus f net over mass and times delta t. And then my practical plan is actually very simple. First of all, I will work with my teammates and record a video of a marker rolling in constant speed, and then I'll put the video in the trackers to do some analysis by calibration and to model the movement. And also I'll use Glow script to produce a theoretical model by coding. And then lastly, I'll use a spreadsheet to compare the data of both scenarios and produce a graph. So now I'm going to explain the practical. So as you can see in the tracker analysis of calibration, I used the point mass function. So you can see those red dots I did in every 1/30 seconds, which is 30 FPS. And I used a blue line to calibrate the length of the ruler so I can record the position of the marker. And then on the right side, you only have to notice the velocity time graph is a straight line with a positive gradient. That means that the velocity is constant, which we can plug in the code later. And then on the bottom, there's a position velocity also with time spreadsheet. So I can use those data later. So now is the coding part, which is quite tricky. And then I use the starter code given by my TA and professors. And I just have to insert the velocity, which is the gradient I got from tracker, and then put the position, which is the first data point of the position versus time graph. And then after that, I just have to use the iteration steps. But remember, f net equals 0 because f equals ma. In constant speed, there's no acceleration. Remember to put it in vector form, so we won't have any vector plus scalar error. And then use the while loop to do the iteration to update the velocity. And now I'm going to talk about the data analysis of this video. So first of all, I use a spreadsheet to compare it. And as you can see, the blue line is the theoretical model, which is a straight line, and it makes sense. But the red line is the real data. And you can see there's only a tiny difference, which means the experiment is quite accurate, but there's still some errors, especially in the before the 0.1 seconds. You can see there's a flat part, which is error we made. So the possible errors include the other external force, which is not in the assumption. For example, air resistance, and also the kinetic friction between the marker and the ground, and also the rounding errors of the calculation. It makes some error, and also the use of significant figures. And also the position tracking and video recording might have some issues because we might record the video too early. That's why there's a straight line. That means that the marker isn't moving at first. And then to be more successful in this experiment, if we reverse the axis, the gradient will be negative. And then there are 4 forces to make it balance. So it's weight, normal reaction force, air resistance, and kinetic friction. So here are the external things. And thank you for listening. I hope you enjoyed this video.